right. This one right here. So they surveyed 1,005 people. They found 76% believe they'll continue working. The confidence level was reported at 95% confidence with a plus or minus 3%. So at this point, we definitely should totally understand where that came from, what this means. Sweet? Good? Yes? No? Good.
Can you step out again? What my arrow tell it?
Let me kind of work up there.
Yeah.
So most of these are pretty straightforward. Like determine the sample size, determine the proportion. They just tell you this. So sometimes you guys still don't quite trust that a few problems, the beginning first questions, there's no work. It's just, can you read and get these numbers? It's really, it's happened a lot in the probability section. It's going to happen in these. So where you're saying you had trouble was which part?
C and
Yeah, identify the confidence level. So again, C is another one. They just tell you. Can you guys see how confident they are in their interval? Now you can because it just kicked in. What was the confidence level? They tell you. Yeah, no work. Can anybody tell me what it was? 95%, yeah. So, and then alpha, you should be able to figure out. What does alpha mean? What's that symbol mean? Area for what? What's a fish got? It's got a tail. So if it's a mutant fish, it's got two. Right? So confidence intervals are mutant fish. This is a phrase I never thought I'd say, and I just did, and I love it. Because they have two tails. So alpha, Greek letter A for area. Fish has tail, or tails, right? So it's the area of the tails. So if I have a 95% confidence interval, what area is in the tails? 5%, done. So there's also, I always forget that the book does this kind of weird thing. Somebody seen that symbol? If you want to pretend like you're doing homework, you can say, yeah, I've seen that.
oh, I think that T.
But it's an A.
It's alpha.
Yeah.
Trust me. Yeah.
I know, but
They make their tail a little bit, they make their fish fat and their tail small like that, right? Or no, all right, whatever it is. Or T, sure, or T alpha over 2. Remember, a subscript just means that that thing is a specific that thing. So not any z-score, the z-score that goes along with the level of confidence they want. And why is it alpha over 2? Because how do I figure out, if I ask you to create a 92% confidence interval, how do you figure out what to look up in the z-score chart? Because I'm evil. There's no 92% is on any of the shortcuts. What are you going to look up on the z-score chart? Huh?
the closest to 92.
No, hell no, no.
0.4.
Yeah, closer.
As the area.
Not 40%, but
0.04.
because that's what's here. Right. What is alpha in this case? What is total alpha? 92% in, which means, so what is half of alpha? 0.04. So that symbol just means it's this score that you would get by looking up half the outside area. I mean, so this doesn't mean shit. You can forget about that. Don't let that freak you out if you see it in the book. It's a subscript just means a specific z-score, the one that corresponds to your confidence interval, and then we go, well, duh, of course, that's the one I'm going to use. So don't let that little symbol in there freak you out. Or do. It's really up to you if you want it. I want it to. All right. It's up to you. However you sound when you freak out. Is that all right? Who asked that question? Is that all right?
Yeah.
Okay.
Since we're already on this problem for A, when they say estimated proportion, is that like what X equals?
Nope. X is a number of things.
Would it be X over like the total?
It's just the percentage. And what percentage do they see from the sample?
76.
Done. Yeah. Why is it estimated? Because that's not the real percentage of all U.S. workers, right? It is the percent they saw from the sample, but it's the best guess I have for the real percentage. And then a confidence interval just kind of builds on that guessing that I'm doing. Yeah. Maybe. You guys all right? Some of you guys have that. What week is this? Some of you guys have that. Is it the 11th week? 10th? I don't even know. Do you guys know what I'm talking about? We have 16 weeks in the semester. Anyway, I'll stop. Anything else from homework? Yes.
1 and 2.
There you are. Oh, yeah.
I just had trouble with the point estimate.
So when they say point estimate, that's another name for best guess. Estimate's kind of like a guess. A point estimate is the word point just means it came from a sample I took. So it's an estimate not based on just me going, I think it's about 40. No, it's got a point. It comes from a sample. So where does it say? Yeah. So let me ask you, if I knew there was a confidence interval from 4 to 8 for a number of an average of something, who cares? Well, what was my X bar? What did X bar have to be? So, yeah, why 6? Why does X bar have to be 6? Because how do I construct 4 and 8? Don't I start with 6 or the mean and then I add something and I subtract the same thing? So won't it always have to be right in the middle of the interval? Cool? So now you've got grosser numbers, but
So I did find the mean, and I had the z-score, but then the standard deviation.
no, you don't need any of what you just said. For number 102, find the point estimate for the mean, so you really just average those.
So how would I find the error?
The error bound, so for example up here, what would the error bound be? How far away from 6 did I go? 2. Error bound's 2. Because what do I do with the error? I add it and subtract it to the mean. So once I figure out the middle, I just see how far away that is from either side. Yeah. Maybe? So this is an example of knowing a problem backwards and forwards. If you know a problem backwards and forwards, you know it. Yeah. Anything else from homework stuff? Okay. Half of you look tired and half of you look like you want to hurt me. It's all right. I'm used to it. Okay, so let's get back into where we left off last time, which would be involving this thing. Who doesn't have this thing? Come get it. We're going to kind of start over a little, I think. We did like the first few, but I might as well start over.
I'm just curious, out of all the tests we've had, what, like, out of all of them, what's the highest that we scored, like, as a class, like, the highest?
Oh, that freaked me the shit out. I don't know.
I don't know, I'm just
Off the
curious.
top of my head, you know, actually, from the grade sheet summary I gave you all the averages.
Oh, yeah, that's
Yeah.
right. I know how much you like numbers, so I thought you know that.
No. I could barely keep you guys straight with my other stats class. I mean, so that was pretty cool. Okay, so for the benefit of those who were not here yet last time, we're going to kind of start over a bit. If you were here last time with me, we did the first few steps of this. If you weren't here last time, you're going to want to watch that video probably, because I try to talk just about the idea behind what we do up here. People give up on these problems a little bit because they feel like it's a lot. It's 5 steps. Why is it taking us so long to do this? Because it's the first one. So I've got to explain the idea behind every step. I'm not going to do that every damn time. Right? Or at least not as in depth as I've been doing around. You're going to work. What are you? Where did I find you? You are. That was an e-learning. So the first thing, just to remind you guys, yes?
Did you say you had to switch a couple of numbers?
Yes, thank you. First thing, just to remind you, is I had turned these around, of course. And don't know if I kind of want to go into why. Anyway, I try to redo this problem to make it make sense, bless you, that we knew the population standard deviation. Do you guys see how, all right, so the group of coyotes that we're working with in this problem, aren't they a subset of all the coyotes I'm talking about in this problem? And if they live in captivity, am I going to have access to the population data? Yes, right? They live in captivity. They're not like out in the wild. So the original way I had this problem was involving coyotes in the wild, and I didn't like it because it wasn't true to life. How would I know anything about all of the coyotes in the wild? Unless I was like, had some weird mutant connection. Oh, I know it. I don't. So this is all about if they are given more room to roam. Room is what you need. Yeah. And this should say with more room. So the basic idea is pretty straightforward, hopefully. Mean lifespan of all coyotes in captivity is 10.15 years. If they are given more room, we take a sample of those and we see 12.45. So on the surface, his claim makes sense. The sample has got a larger lifespan, a longer lifespan. Why can't I just stop there and go, there you go, we proved it. Done. Next problem. World hunger? No problem. Why can't you guys understand what I'm saying in the first place? His claim is they live longer. They live 10.15 in general. In captivity, the sample I took lived 12.45 years on average. Is that more? All right, why are we not done? Why aren't we done? And I'm sure somebody out there is like, what is he doing? We know the answer already. 12.45 bigger than 10.15, Jeff. Why can't I just stop? Does anybody know?
Test the hypothesis?
Sure, but that's just me saying that because I like math and I want to make you do a lot of it. Because it's just a sample. Any sample I take could just have random fluctuations. I could just happen to pick a bunch of coyotes that were going to live long no matter what. You guys with me? That could happen randomly. So I need to check, is the chances of that happen randomly, are they so small that it's actually evidence that they do live longer altogether, the whole population? So basically, not only does a sample have to match the claim, but it's got to be so far in that direction, in this case, so far up. And how do we measure distance in statistics? Z-score. So I'm going to set a benchmark Z-score that I want my sample to hit. Okay, all right. So the real fundamental idea behind this, I know there's 5 steps. All the steps are important. The 2 most important steps are the 3rd step and the 4th step. The 3rd step says, where does evidence start? And the 4th step says, okay, did the evidence go? Did I find enough evidence or not? Maybe. So if I was, even if you don't like football, if I was the coach of a football team and all my players were slow as shit, right? Slow as molasses in January, is what I'm saying. Right? You guys with me? Do you think it's really good to have all my players are slow? They better be freaking tanks then, but even then I want somebody to be a little rocket that I can just shoot off the sideline and throw a Hail Mary pass and pray. No, yes, maybe. Even if you hate football, I just want somebody fast on my sports team so ball going good, right? If you want to look at all sports as well. Okay, so I set up a test. I have people that want to join my team, and I set up a little test, and I say, I want you to run the 100 yards, but you got to do it faster than this benchmark. And I let them run. I take a sample of their run times. Because if I only let them run once, is there a chance they could have stumbled at some point, or there was like a loose part of the field, and then they just barely missed the cutoff? I'm going to let them run several times. Do you guys believe me? And take a sample. So what's going to be evidence that they should be on the team? I set a benchmark time, and they better pass that benchmark. They better do better than that. That's really all this is at the heart. I set up how far away would be evidence to me. not only do you have to be different from the mean, the in this case the 10.15, you have to be different enough. So I set up a benchmark, and then I just see, where did the sample fall? Did it fall far enough or not far enough? Okay, maybe. So, and also this. Remind me, HO. What's the official way to say that? The what? What is this? Null hypothesis. And it's also affectionately known as the, oh, okay. The null hypothesis must always have what in it? Equal sign. So this could be, for example, something like this, and that would be fine, right? And then what would this one be?
The opposite.
Yes, and what's the opposite in this case? Careful. Less than. If the first one already includes 7, the opposite can't. So with inequalities, you're only going to have one of them having an equal sign. Otherwise, who the hell should go in for the null hypothesis, right? Now, are you all cool with, I'm pretty sure I must have said this. This is where teaching 2 stats courses gets really weird. I'm like, I said that already. No, not for these kids. Can I take a sample and show evidence that the mean equals something? So let me say this. If you thought the average age of gross month students is 25, and I take a sample and their average age is 25, does that prove my claim? No. Why? Because any sample could be different. In fact, in a sense, it's almost proof that it ain't. Because most samples probably wouldn't be equal to the mean. Okay. All right. I'm not being 100% technical here, but it's still pretty close. So which statement up here can I actually show evidence for? The one that does not have an equal sign. This dude, so if I draw this picture, here's 7. This guy thinks it's in here somewhere. This guy thinks it's down there somewhere. You guys with me? That's what it says, right? Thinks it's less than 7, this guy's. So not only do I have to be less than 7, that's not good enough. I gotta be less than 7 enough. I've gotta be down here. If I get a sample in here, does it look like the guy that thinks it's here is right? No. I can say this guy's wrong in that case. I can say it looks like this guy's right. Okay, maybe. Let's see how this goes. So what is the claim that's being made? I was really nice and I bolded the important parts. So what's the claim that's being made? What does Phil think? They live longer in captivity if they're given more room, right? So that says the average lifespan, if they're given more room, is longer than what? 10.15. The number that will never show up in the hypotheses is anything to do with the sample, right? Why are we doing the test in the first place? Because somebody, or me or somebody, has a belief about, I claim this, I think this. I have to have that first, and then I go take a sample. All right, so longer, mathish, what's that in mathish? Greater, it's crazy. Greater than what? 10.15. So we think that if you give them more room to roam, they live longer than, greater than what the others do, everybody does in captivity period. Which one is that? Which one? Say it loud and proud. I love you guys. The high. Why the high? Why is it not the hook? It doesn't have an equal sign. It can't be there. So the way that we set these up, the way that we do this, is so that all the other steps are always the same. So the high has got to be the one I can show evidence for. So that's why it doesn't have an equal sign. And the ho is the opposite of that, or if the claim had an equal sign, it would go here. So what's the ho going to be? You. So there's your 2 old men in the coffee shop with different opinions. Yes?
So anytime write your claim, that's always, you can just always put that as your
No. In fact, the next problem we're going to do together, you know I've got more worksheets with more. We've got like 4 more hypothesis tests we're going to do today. Holy shit. Yay, this is awesome. All right. Why did I put the claim in where it said, in the high? Why? Because my claim did not have the equal sign. So couldn't somebody claim, I think it equals 7? So then it would go in the home. So if I write, that's why I make you guys write the claim first and then figure out where it goes. And then who's the other guy? Opposite.
But it's bound to be one of those two.
It's gotta be, right? Because it's the one that gets everything going, and then the other one is the opposite of what that claim is. Yeah, in this case, it went into the high because there's no equal sign. How many tail tests is this going to be? Whoa. What's the only way to show evidence for greater than? Where would it have to be on here? It'd have to be up here somewhere, right? So it's a one-tail test. Do you guys see that? If there is a direction to the high, it's a one-tail test. Greater than, one tail up there. Less than, one tail down there. That almost sounds like a dance song. What's the only way it's going to be two-tail is if the high is what? Not equal to. How can you be not equal to something? You can either be less or greater. Two-tail test, then. Either way shows evidence. So really, the tail test is which direction is going to show evidence. What's the only way to show evidence something's bigger than something? To get something way up there. All right, it's one tail. In fact, that points you in the direction of the frickin' tail, right? Yes? A little arrow? That way. Okay. All right. Yes?
So we'll always know if it's one tail or two tail based off of our claim if it has the
Based off of your H1.
Okay.
In this case, that is the claim, but
But not always.
I want you to, I'm going to say this many times. The claim is what gets everything started, and then I forget about it until the end. Claim's got nothing to do. After I write it, I forget about it. Right? Or you forget about it, whatever dialect you're writing is.
For the claim, is it always going to be like in relation to the mean, or?
Well, it's got to be in relation to something, some accepted amount. Or somebody says it's 8, and I'm like, I think it's not 8. So the claim is it doesn't equal 8. It just is based on either some historically known number, some truly just known number, or something somebody said. So there's got to be something that makes you say this claim. I think it's not 8. Why do I? Because he thinks it's 8, and I think he's wrong. It has nothing to do with you. Anyway. Also, we are going to do hypothesis tests for percentages. So then it'll be like, I think the percentage is more than 22%. So then P greater than 0.22, I put that in. Yes. Yes.
So, the tail test is based off the claim or H1?
H1. Don't worry, we're going to do a problem right after this one
Always H1.
where the claim is in, yeah. And again, why? Because the test tells me how to show evidence for something. And what's the only thing I can ever show evidence for? The one without an equal sign. That's why this guy always sets it up. Okay. I love you guys. How many of these problems have we done? Not even one yet. So it is going to take some time to get it to sink in your brain. That's just the way it works. Here's something that sounds very familiar. So step 2 of this 5-step process is old news. Can I use Z-scores, T-scores, or do nothing? You got to tell me 2 things. What tells me I can do something? Just something, anything. What tells me I can actually do something? Does it say that it's normally distributed? It doesn't say it. Shit. Oh, shit. Oh, shit. We're stuck. Great. That has nothing to do with what I'm talking about right now. Not yet. That's going to be determining which score I can use. I don't even know if I could do anything yet. You guys haven't even told me that. It doesn't say it's normal. What saves my ass? N is, which is bigger than 30. So this step here tells me I can do something. Check. And then, like you said, was it Kansas? We know sigma. Don't we know sigma? Not just we know the standard deviation. That don't make any damn sense. Which standard deviation? We know population. I made it bold and blue. Damn. Don't get used to that. So that means I can do what? I can use z-scores.
Yay!
Because if you didn't have that,
If I only knew S, I'd have to use t-scores. And we're going to see the t-score chart is set up beautifully for a hypothesis test because they could be 1 or 2 tailed, just like the t-score chart has 1 and 2 tailed. And you're like, that doesn't make up for the fact that it exists large. What about the next step? So now I know I can use z-scores. Alpha's 0.01. It's a one-tailed test. Can you guys put that together and figure out what the z-score? I'm going to be insane, and I'm going to use the t-score chart. If I have one, I might have given my last one. Oh, here it is.
Yay!
Why can I use the t-score chart to find z-scores? Because they are at the bottom. So what I got? I got one tail test, right? Alpha is 0.01, one tail, 0.01, and then don't stop. Yeah. If I stop, I get a t-score. If I don't stop, I get a z-score. Yes, maybe? No? So 2.326. And why is it positive? Not because the chart said so. Why is it positive? Because it is. It's. Why is it positive?
because it's above
Above the mean. What? Yes.
On the z-score, it says 2.33. Is that like what it
Oh.
is? I mean, I know you round. It's like,
Because remember, the z-score chart rounds to 2 places.
yeah.
To make
so
it easier.
Would it be okay
If you do that, that's beautiful. So I don't care which chart you use, but the t-score chart does take it out one more place. Yeah. So how do I write this in words? Okay, so I think this is how far we made it last time. I think I have it. Yeah, see, we made it that far. Ooh, look at that. So this is where the null hypothesis thinks things are. So what area do I have to get my sample into to show evidence that that is wrong? Yeah, so I shade this in. So when I say define the rejection region, this is that. That's a visual definition. There's the rejection region right there. No, it's not like the friend zone. So if I get in there, so this is where the null thinks that things are, right? So if my sample gets there, that is evidence that the null is wrong. So therefore, at the same time, that's evidence that the high is right. Maybe. So I've set up my benchmark, just like the guy running to try to get on my team. That's the benchmark. You better run faster than that, or else you can't get on my team. Yes?
Is that enough to like define the rejection region? It's just put the z-score and shade? That's
Yep. And then what else do I say?
Oh, but it's
Yeah, dude. So what's this mean? If the z-score I calculate from the sample, real quick, I want you guys to really believe why I did this. And this is just me. I'm insane, as you all know. But do I not already have a z-score on the paper? Where's the z-score I have? Right there, right? Is that the z-score that I calculated from my sample? No, I looked that up, right? So I call the z-score that I'm going to calculate from a sample, I call it z-star, just to differentiate it. There's a few z-scores on this damn thing. So if my sample is further up than 2.326 steps, standard deviations, then like we just said, that is evidence that the guy who thinks it's in the middle is wrong. And it's the hoe that thinks it's in the middle, the null hypothesis. So I can reject the support the high. Sounds like propositions we voted on. Or not. That's why I love teaching college. If I offend you, just wait a few minutes, I'll do it again. Is it ready? Continue. So these are the two most important steps. Part C says that is enough evidence. And then what do? Part D, I go see what the evidence is. Is it enough? So part C says, where does my sample have to fall? And then part D, I see where my sample fell. That makes almost too much sense. So in this step, I'm just calculating a z-score, the same old formula. What do I know from the sample? What's n? 41, thank you. What's the standard deviation? 4.27. So what's the new standard deviation that I need? Because I'm talking about 41 things, right? What do I do? 4.27 divided by? How do I get the new standard deviation? Square root of 41. I need the one that works for groups of 41.
I thought that 2.326 is already started.
Hell no. No. Bless you. That's the whole reason 2.326 is what the book calls the critical z-score. That actually makes sense. That's the benchmark. Right? That's the z-score that you have to pass to show evidence. You guys with me?
This is the actual calculator.
And then Z star is now I want to see where did the sample fall. So all that number is here is the dividing line between not enough evidence and enough evidence. So then Z star is going to be the actual Z score for my sample. Where did it fall? Did it fall far enough away?
Is there a reason why we use 0.01, or is that just a random number?
I just picked it out of my head. In real life, you will never see an alpha in a journal article. Alpha is sort of like our own personal what's enough evidence. Do you think that everybody has the same level of evidence for something? No, right? There are people that think the earth is flat. So obviously, you don't have the same level of evidence, plus stupidity reigns supreme, right? If you are a flat earther, you are dumb. Okay. Just to be clear. Yeah. No, you're not a group of people that I need to be careful about. I just want to somebody coming out and say, if you don't trust me, you should see some YouTube shit about people that think the earth is flat. It's really amazing. I thought we left that back in the 1600s or BCs. Hello. There, help me out. What is this? Please shut me up. Get me back on this. What is 4.27 divided by the square